Hello everyone, this is Mark Osborne, Senior News Editor at PVtech and the webinar moderator for this Tech Talk product series today. Our partner is RainWise, which is introducing its PVmet 500 modular weather station for both commercial and utility scale PV power plants. We have two experts from RainWise to cover this topic, which is maximising PV power plant ROI with modular solar monitoring weather stations. This includes Carsten Steenberg, VP of Product Management, and Eric Rollins, Sales Director at RainWise. Please use the questions section throughout the Tech Talk, as we'll have RainWise people here to help. We'll also have around 10 minutes for Q&A at the end. Right, that's it from me at this point, and I'll just hand over to Carsten. Carsten, are you ready? The floor is yours. Thank you.
Thank you so much, Mark, and thank you for the participant of this webinar. I appreciate your time with us today. So I'm just going to go through some few slides, but primarily focusing on PV monitoring and why it's important, and then Eric will mention a little bit of the product we are highlighting, the PVmet 500. So RainWise. So RainWise is an old company in this space, and we've been in this for more than 45 years, way before solar was a mainstream for sure. The name RainWise comes from the first product we have was the tipping rain bucket, and we were the first company in the world to actually have a worldwide patent for that. And this is the system that everybody used to measure rainfall today. So we were proud of that. Soon after that, we focused on full weather stations and monitoring all key parameters. And we were actually the first company in the world to make a compact weather stations, also very used for consumer rooftops in the fields, etc. And then later on, we enhanced that to be a wireless version with solar power technology. And in many ways, RainWise created the concept or the market segment called personal weather stations. You can also see in the picture below that beyond solar, we cover many other areas of weather monitoring, and but solar is our favorite and probably our key focus right now. So RainWise stepped into the solar monitoring marketplace kind of in the real peak in 2010, and the first product we have, which is still our best seller, is the PVmet 200. Shortly after, we were invited by an outfit out in California, US, to be involved in optimizing a new standard that is global for anything related to solar plants. And we were treated as the expert to co-write the specs for the weather stations with the SunSpec standard, very much focusing on identify the Modbus registers and the order, etc. Also, the jumpstart was from a relationship with a company in US called Power One, and they start selling their our weather station with their branding. And Power One was acquired by ABB, and later recently by the Italian company PVmet. And also SMA in Germany is now selling two of our products with their branding on, and we're proud to have ABB, PVmet, and SMA is all among the top 4 in terms of inverter companies in the world. From 2010 to today, we have more than 8,000 PVmet units installed worldwide, and they are monitoring more than 2 gigawatt of power. So quite a bit there. Why is PV monitoring important? It's very important that you actually have a secondary way to figured out what's going on your solar plant, and not just see what your actual production is according to the inverter values. Many plants are third-party financed, and the financing authority demand that there is a kind of a redundancy in checking the performance. So it's optimizing performance, finding faults, errors, inefficiencies, but also to prevent possible damage. Often, you can see if there's dirt on the panels or snow, but also if there's a storm coming, you can know that right ahead by having the wind sensor there. So just to focus on what are the key parameters do you need for a solar monitoring weather station. And it's really two most important parameters is that the intensity of the sun. What is the intensity hitting the solar panels? And that's normally plane of array is exactly the angle of the same angle that hits the solar panel, and global is just the intensity of the sun general. And then it is the fact that the temperature is very important for the panels. The cooler the temperatures are, the more the output is from the panel. So we actually monitor the backside of the solar panels with a via thermal block. If you have those two parameters and know the size of the solar panel installation, then you can actually calculate what the optimal output should be at this present moment. And that is very important to compare those value and that estimated calculation for what the real value see, and see if there's any delta between those two values. And take it a little closer in to say, like, why weather stations at the PV plant? We all, RainWise had known for a while, but I think there's a general understanding also by farmers and also PV plant that microclimate is a reality. You know that the weather can be, you talk to your friends over the phone, and the weather can be very different, even they're close by to what in your backyard. It could be temperatures, it can be rain, it can be wind. It's really, the weather cannot just be an approximately expectation of what is actually reading at this point of time at the local airport or the nearby airport. So to have wind sensor or to have weather stations locally is important also on PV plants. There's an example very recently from a major European independent power producer that basically had a great excess of energy produced, but it was a surprise for them because they just based their forecast based on forecasted data or nearby data, not on site. Yes, they produced more than expected. That's the good news. But had they known at that time, they probably could have done better revenue because they had planned to get the proper people to take more power, peak demand, etc., etc. The other thing is that, I mentioned before, solar panels are really like sails on a sailboat. And if there's a storm coming, they can be ripped apart, or the trackers can be damaged, the gears, the motors, etc. And it is actually a fact that the most common damage of PV system is due to the wind. So if you have the information that the wind is increasing, it can be an automatically value that the tracker gets. Okay, it's increasing and we're reaching this threshold of wind speed, and then we can actually make the tracker, make the panels horizontal so the wind is not catching the solar panel like a sail anymore. The hottest topic these days in general in terms of technology on PV is the new technology of bifacial solar panels. So I'm going to use the next slide to go a little more in detail on that. So bifacial solar panels and the monitoring to that, also called monitoring the albedo, which is kind of the reflection from the ground. It's a very promising technology because in a sense you say, okay, we have the same footprint and now we can, in perfect condition, we can have 25 to 30% extra production based on the backside of a solar panel. So with that in mind, we expect that up to 50% of installation will use bifacial solar panels within the next 10 years. But there's a lot of unknowns. And one thing here, just to mention one factor, people say, okay, but how do we measure this and where do we place a sensor or albedo sensor? And, just to mention one thing here, we can say that, we found out that around 60% height of the complete structure is where you place the sensor pointing downwards for the albedo measurements. So in general, the optimal way, there's two optimal ways to monitor albedo, or the sun that measure or that hits the bifacial panel on the bottom. Is the one I like the best is really number one, where you basically have a planar ray sensor pointing up, really hitting the top, and likewise you have a irradiance sensors 180 degrees opposite pointing down that represent exactly the solar rays diffused or from the ground that hits the bottom. And then, but the other way that some prefer is that you basically just have the standard global and where you have a sensor pointing up and pointing down, and then using software to with algorithms to calculate the planar ray that hitting the backside of the panels. But there's many considerations here to really find the sweet spot of using the bifacial solar panel in an optimal way. A lot of you have heard about 1P, 2P, and it's really a matter like, how many panels do you put on there? Do you have a bigger area, you have more things you cover, and therefore you introduce less albedo effect, meaning there's less reflection from the ground. So there's questions on how close do you keep the rows together with the trackers, and how many panels you keep there. What are you doing in terms of ground cover? Wet grass is not good. Do you put white plastic on, or what do you do? Of course, if it's on a roof, you probably have more control over that. But there's many different parameters that you have to find out what is the sweet spot. And I don't think we know yet. But having that in mind, you would say that it's absolutely important that any solar plant that are using the new bifacial solar panels must do the monitoring in order to fine-tune their optimal sweet spot here. So it's an exciting technology, but there's a lot for us to learn still. So with all that in mind, what is the perfect weather station today? What do you need to have in mind? First of all, I think you need to make sure that your investment is guaranteed a long while, and that you have modular ways of expanding to additional sensors. And the most important sensor of a solar power and a solar PV weather station is really the irradiance sensors. And we work with all the key vendors, Kip and Sonnen, Husker Flux, EKO, and you want to make sure that if there's new technology coming there that is better, more accurate, that we actually can support them. And that is very important that you have that flexibility. And of course, it has to be easy to install. It has to support various standards there, have to be supported by majority of inverter companies and solar monitoring software, and following key standards. And as we just mentioned, it should be capable of monitoring bifacial panels, and also have future upgrades in terms of communication standards as well. So with that in mind, I will give the words to Erik Rowlands. You are the expert on the PVmet 500, Erik, so please go ahead.
Thank you, Karsten. The PVmet 500 was designed to meet the evolving requirements we were seeing for PV monitoring. As you can see in the first bullet point there, the 500 can integrate, can help monitor, global, plane of array, and then, obviously everybody's aware of the ongoing need for bifacial panels. We can do the albedo and diffused. You can integrate with the 500 pretty much any technology of solar irradiance. So that includes all the way from your simple silicon diode sensor and reference cells all the way up through what we call thermopile technologies, your high-end irradiance sensors, and they're class A, B, and C, and the 500 works beautifully with those. It meets the one big thing especially in the last 2 to 3 years, we see the ongoing requirements to meet the IEC 61724-1 monitoring standards, and the 500 was designed with that in mind. So all the sensors, the temperature, wind speed, all the sensors on the 500 meet the minimum requirements or exceed the requirements for that spec. And we do see that the more requirements I come across my desk, I see this need. So the PVmet 500 it has a full array of sensors, all the way from barometric pressure, relative humidity, ambient temperature. You got your choice of mechanical wind speed or ultrasonic wind. You can have up to 3 solar radiance sensors, and that can be mixed and matched as well. Like you could have 1 reference cell and 2 thermopiles, or whatever way you want to do that. Also up to 3 panel temperature sensors, and you can also integrate a rain gauge as well. We have easy connectivity with your inverters or data loggers through Modbus RTU via RS-45 connection. And like Karsten mentioned before, in the future we will have a TCP version, and right now we can meet that need by using a converter for RTU to TCP. Here you see the motherboard of the PVmet 500, and you can see how simple the configuration can be using push terminal connections. And you can see where we thought about shielding and grounding, especially with lightning protection. The electrical connection on this is very well, and you can also, it's very easy to upgrade in the future for if your requirements get stricter or more needs for albedo or whatever. We've been very happy with the success of the PVmet full product line, mainly because of how compact these weather stations are and easy to install. They're all on 1 single mast, ready to go. EPCs love these because you pull them out of the box, they're fully assembled. You can have them up and running within minutes. What adds to the success is the compatibility, for the sun spec, and our compatibility with almost all inverter manufacturers and PV monitoring solutions, including we've worked very close with SolarLog, Medio Control. We've worked with Also Energy. Like Karsten mentioned before, SMA and ABB, which is now FEMA, have OEM'd our weather station. We work with SunGrow, Huawei. We work with all major manufacturers. There's many models to choose from, all the way from the PVmet 75, which is, we call it, our entry-level weather station, which is, just your simple solar irradiance, ambient temperature, backup panel temp, all the way up through so many different combinations through your PVmet 500 that can meet any requirement. We're very proud to say that we have become the standard weather station for PV monitoring projects. And I'll pass it back to you, Karsten.
Thank you so much, Erik. I'll talk a little bit about the application for the PVmet 500 and the PVmet in general. But our sweet spot for the PVmet 500 is very much also in line with some of the earlier model, but it is maybe not smaller utility grade, but utility grade and also commercial. And the commercial ones that I like to emphasize are that we have a lot of going on around the world is like the big box store and warehouses, like companies like IKEA, Walmart, and Target. Their rooftops are often covered with solar panels, and we are normally part of that system. There's many institutional buildings, colleges, universities, municipalities around the world, and there's also several countries that have state or they have countrywide applications where they are using for towns and cities, and we happen to be part of that. And we, again, like the 8,000 units, they are spread all over the world and over 4 different continents. Excuse me. I'm very excited about saying that we just got involved with a big monitoring project in Vietnam, Sao Mei Solar Power, and that is a 210 megawatt utility grade system. So great example that they saw the PVmet 500 was the ultimate choice for that. So the PVmet 500 with the R2 Modbus with the RS45 is available today. You can list this. I click on this link and it will take you to a form where you can fill out and get more information about the product. And then, as we said, in early next year, we will have the Ethernet TCP system available as well. We are here to help, and not everybody can be expert at solar monitoring or PV stations for that purpose, and we're happy to help and guide you if there's questions or tenders you work with. We're here to help, and we will love to work with you. I'm so happy that you spent the time for this webinar, and I welcome you to contact us, contact Eric, and we look forward to working with you. Thanks again. We appreciate you being here.
Well, thank you there, Carsten and Eric. Really good presentation. Certainly, there's been some really good questions coming through. A little bit of a theme for both of you is applications regarding, or the technology that you may have that relates to soiling. So the actual module soiling and how this, obviously they're talking about the different challenges with this, but perhaps Eric, you could give us some idea on what technology is used for soiling, if there is one available.
Yeah, thanks, Mark. We don't actually manufacture a solution for soiling, but when we spec out projects, we work with a company called Autonometrics. They have a Mars soiling sensor, and we also do some work with the Kip and Zonin soiling sensor. And it's usually brought into the SCADA or the monitoring system separate from the PVmet 500. It's more of a separate system, but our PVmet systems do work side by side with those soiling technologies.
And I'm assuming on from a soiling point of view, there was another question sort of indirectly related here about the accuracy of measuring irradiance, especially when the system will collect dust particles similar to what the actual modules is happening, but that's obviously not the type of technology that would be more accurate for the soiling.
Right. I mean, if they're talking about the solar radiance losing accuracy because of soiling, that is why we brought in the rain gauge to the PVmet 500, so you could have an idea of when it has rained to see if possibly the domes on the solar radiance sensors have been cleaned off by the rain. And a lot of, and if not, you may have to go out and clean them yourselves.
Right, got it. Question here, does an EPC have to install, I'm assuming, a weather station on every single project? What if you have sites that are, say, 20 minutes drive away? So what's the best practice there, I guess, is the advice they're asking for.
Well, like Karsten mentioned in his talk, there are microclimates. So even being 20 minutes away, the weather could be completely different than the site. Depending on the size and how strict your monitoring requirements are, it depends on how many weather stations you should have. But you should have one weather station on your site, minimum.
Okay. Another techie on the PVmet 500, does it have a rain gauge sensor?
Yes, the PVmet 500 can integrate a rain gauge, and we actually have two different options. We have one that's made out of a poly plastic type material. It's a lower cost rain gauge, and it's both rain gauge options are tipping bucket technology. And then we actually have one that's made out of anodized aluminum that has a higher accuracy down to we can get it down to almost 1% with a 1 millimeter tip. Depending on your requirements. I mean, it's funny, I see requirements and tenders come in from all over the world, and you're amazed at how strict some areas are compared to others on sensor requirements. So that's why we have two different options.
Back with the calculations, is there a model that calculates the measurement data about the energy we should get from the weather conditions that have been measured?
There are, but that's not our wheelhouse. We typically leave that to the monitoring companies to figure out, because they're the ones obviously that have put the time and work into the software. We're just the hardware that will work with the monitoring solution. Another one related actually to that. I mean, I know good best practices with PV power plants have long advocated that when you've actually got a planned PV power plant, you actually put a remote weather station on there for as long as you can, just so that you're getting that microclimate analysis. Do you do a similar type of system that's sort of obviously self-powered? Actually, yes. It's funny you say that because I'm working on a system right now to do that same thing. The purchase hasn't happened, but I'm working with a customer right now, and they're setting up a PVmet 500 with a global, a diffuse paranometer, all secondary standard, and an albedo. And they're going to, I can't remember what the amount of time was. I think it was a minimum of 6 months to assess the site. And they're also using a gateway and cell modem with and the power supply they're going to use is I think it's a 50-watt solar panel battery charge controller system. So it's all self-powered. And we've done a couple of those, but I'm happy to be working on one right now. Okay.
I'm looking at the time. Maybe can get one final quick one in here. In light of due diligence and net minimum guaranteed generation, is there a need of periodic calibration for the weather stations?
There is on the paranometers. Those are probably your most sensitive sensor for calibration, and it all depends on the manufacturer. Like ACO, their MS80, which is secondary standard, they suggest 5 years, but I would say most average every 2 years. And then, but there can be, depending on the IEC, like the IEC spec, there's class A is every 1 year. So you have to watch what your requirements are or go by the manufacturer's suggested calibration time.
Right, Eric.
Okay, well, guys, I think that's the end of the presentation side. I just want to thank both of you, Karsten and Eric, once again for this really informative presentation. Just to let attendees know that the RainWise staff will be here for about another 15 minutes on the platform, even when the presentation slides on the left disappear. to answer any more of your questions. And just thank you once again to everybody for being here today. And we look forward to seeing you during our next webinar. Thank you very much, and goodbye.
Thank you.